Hey everyone, a very warm welcome to my channel. So you guys are watching e-learning with Suruchi and I'm your educator Suruchi Mahato. So today's topic is expression for Maxwell and Clausius mean free path, right? So without wasting the time, let's get started. So this is the expression for Maxwell mean free path. I have write by my own by research on that. I've studied on Maxwell mean free path and I got this derivation. So let us consider two molecules of masses m1 and m2 and diameters d1 and d2. When they collide, they can be considered as one body system having reduced mass mu equal to m1 m2 by m1 plus m2 and center to center distance d equal to d1 plus d2 by 2. So let the number of densities of these gases are n1 and n2. We construct a cylinder of cross sectional area pi r2 and length v bar equal to root over of 8 k beta t by mu t, which defines average speed characteristics Maxwellian molecule, right? So if you are going to discuss about the average speed characteristics of Maxwellian molecule, then you need to write this formula. Okay, so I have considered a cylinder over here, okay, whose length is v bar and the diameter is d. Okay, so when the molecules of first type moves, it will collide with all the molecules of the second type contained in the cylinder. The total number of such collision is given by F12 equal to, so the total number of collision is considered as F12, okay, equal to n2 pi d square v bar. So this is the formula. Now I'm going to put the value of v bar over here, as you can see, and after that I'm going to resolve that. So what you get is n2 pi d square root over of 8 k b t by pi and 1 by m1 plus 1 by m2 over half. If all the molecules are identical, we can write d1 equal to d2 equal to d1 and m1 equal to m2 equal to m, say, and n1 equal to n2 equal to n. So you have to consider every molecules and everything. If all the molecules are identical, then there must be their volume, their diameters and their numbers must be same, right? So I have considered everything as same value, like d1 equal to d1 d2 equal to d and m1 and m2 equal to m and n1 n2 is equivalent to n. So using this in the expression for f12, which are redesignate of f, we get f equal to n pi d square root over of 2 into 8 k beta t by n pi equal to root 2 pi n d square v. Hence lambda equal to v bar by f equal to v bar by root over of 2 pi d square v, and this is how you will get the value of lambda. So this is the particular expression for Maxwell mean free path. Now let's talk about the Clausius mean free path expression, right? So in Clausius mean free path, I have considered a parallelogram, okay, with a point where it goes C2 and over there C1, and I have considered an angle pi minus theta. And after that I have put the vector formula. As you can all know that it's a resultant vector. A and B are at the same direction and resultant is at the opposite direction. So I have put the value like r equal to root over of c1 square plus c2 square minus 2 c1 c2 cos theta. Now d and theta 1 phi is equal to number of molecules moving along theta and theta plus d theta and phi and d phi direction. Average relative velocity of pi with respect to b type molecules will be r bar equal to integration of r d n theta phi by integration of d n theta 1 phi. Now if we resolve it out, then you will get that n by pi integration of c1 square plus c2 square minus 2 c1 c2 cos theta. It's under root over, so I have put to the power half. Now I'm going to consider n d omega by 4 pi is equal to, I'm consider d omega equal to r square sine theta d theta d phi as a spherical coordinate system, right? And after that I have solved it out. So by putting the value of n d omega by 4 pi, I got this much, and I've put the limit from 0 to pi, right? And after that c1 c2 get common, and I let c1 square plus c2 square minus c1 c2 cos theta will be z, and after differentiating out you will get that both are constant, so it will be 0 and this will become 2 c1 c2 sin theta d theta. So after differentiating cos theta, it will be minus of sin theta, and minus will become plus, and it will help like that. So after that, after getting the value, I put the value dz over here and z to the power half over here pi considered is as like that. Okay, now I have put the limit c1 minus c2. It's a possibility that c1 might be bigger than c1 or c2 might be bigger than c1. It's not, we're not sure about, that's what I have put differentiation mark over here. You can, if you are sure about, then you will definitely put minus over here. And the upper limit should be c1 plus c2 whole square, because I am very much sure, because if we put c1 behind or c2 behind, it will definitely put plus over here, cause plus will never change out. And after resolving it out, we will get r bar value, that will be 1 by 6 c1 c2 bracket over of c1 plus c2 whole cube minus c1 differentiation of c2 whole cube. So let us assume that c1 equal to c2 equal to c bar, and r equal to 1 by 6 c bar square 8 c to the power 3 is equal to 4 by 3 c bar. So after getting the value of r bar, I got the value of lambda. You can see that, and after resolving it out, you will get the value, that is lambda equal to 3 by 4 1 by pi sigma square n. So this was it. If you like my channel, please go like, share and subscribe, and please don't forget to press the bell icon so that you can get the notification earlier. And thank you so much for watching. Have a nice day.